Before we get into joint structure, I would like to do a quick anatomy of the joints. So over here we have muscle attached to a tendon connected to the bone on the top. It is protected from the what's called the bursa, which basically reduces the friction that a muscle would have caused if it was in direct contact with the bone. We have the joint capsule over here, which is like protects, encases the joints and allows the synovial fluid to freely flow through it, within it, to reduce friction. And we have the articular cartilage, which are attached to these bone ends so that to further, again, enhance the smoothness of it, so that there's very, very little friction loss. Okay, so joint stability is the ability of the joint to maintain the functional position in its specified range. When a joint is formed, it basically has some function, and mostly it's to maintain some physical configuration. So like the joints on your knee would allow you to move the knee extension and flexing, but not that much to the right and left. Joints also are meant to have load-bearing capabilities, so that load applied from the top can be transferred through to the bottom. As is the case with the knee joint needs to take the weight of the body and pass it on to the leg. It also needs to have shock absorbing capabilities with joint lubrication. Again, joint lubrication is to reduce friction, and the shock absorbing capability is basically if there was a case where the load transfer has for a moment a high impact, it needs to be able to withstand that temporarily. And we can see that this joint capsule does help, along with the synovial fluid inside. And lastly, it's an important static stabilizer, which means this bone really isn't connected in any way. It's not like a ball and socket joint or a pin joint where it has some reaction forces. In this case, it's just like two joints together, and so this configuration of the joint allows it to be statically stable. If a force was applied here, the synovial fluid with the capsule will be able to withstand some of the force. And I didn't mention it, but there are tendons that connect these two bones together, which act as that static stabilizer. Okay, so some of the characteristics here. So number one, we need to have articular surface contact. In this case, what it allows the bones to do is transfer the load directly from one to another. And this articular surface, which is this green over here, which is covered with the bone, will allow the force coming from above to be easily transferred, efficiently transferred from this bone to another bone, despite there being fluid around it, and which reduces the friction. Despite all that, it's still, the surface will allow it to physically transfer it. And it's not in a sense where there will be like a pressure change that's going to carry on the force, which would cause these walls of the capsule to be heavily burdened. So this helps the force transfer. Muscle actions also help stabilize the joints. And how they do that is, in the case that these joints cannot apply force to return it back to its state, its configuration, or that, let's say, there's an external force being applied, then these muscles will allow it to stay in the state that it needs to be. And we can see that like in our eye muscles and other places, where this muscle is going to keep it in its configuration that you left it at. And so, yeah, muscles do play an important role in the stability of joints. even though many muscles, especially the skeletal muscles, are used to apply external forces and to produce motion. And there's the multi-condylar. And what this does is allows a primary movement in one plane. So it allows the movement of this, in this case, the knee, to move in one plane. But due to this disc shape, these are disc shape. Due to this disc shape, it is able to slightly allow rotation in this direction, as you can see, in this direction. And so this allows it to have stability, but also some give to the knee structure, which is pretty nice.